Good evening all. Welcome back to NPTEL PMRF tutorials on Introductory Organic Chemistry 2 by Professor Harinath Chakrapani and Professor Neeraja Deshaputre. Myself Anisha Suresh, PMRF TA for this course. I will be conducting weekly live sessions on Tuesdays from 6 to 7 pm. Today we will be going to discuss about week 1 assignment of previous year. Can we move towards question number 1? Can we move towards question number 1? Coming towards question number 1, the question is, which of the following have the correct arrow pushing sequence? They have given an electrophilic aromatic nitration reaction and they have asked for the correct arrow pushing sequence, and 4 different options are given. We can see which is the correct option. Coming towards option number D, here the structure of this nitronium ion is itself wrong. A nitronium ion is having a structure similar to this, where there is a positive charge on nitrogen. So here they have written the structure of nitronium ion itself wrong. So this option D can be ruled out. Is it clear? Coming towards option C, here they have given that the electron-rich aromatic benzene system will attack on this positively charged nitrogen atom, and the electron density that will be pushed towards this oxygen atom will come and attack on the carbocation that will be generated here. Here a carbocation will be generated. So it will result in a 4-membered species. So this option is also not right for nitration. Now coming towards option B, here they have mentioned that this electronegative oxygen atom is going and attacking on this electron-rich benzene system. So this option is against all the concept. So this we can rule out. Now moving towards option A, here they have shown that the electron-rich benzene ring will attack on the positively charged nitrogen atom, and the electron density will be pushed towards oxygen. So let us see if it is the correct mechanism. We can see the mechanism of electrophilic nitration reaction, and this is the mechanism. As we know, this is the nitronium ion, the key intermediate in electrophilic nitration reaction. So how nitronium ion is generated? It is generated by reaction of nitric acid and sulfuric acid. As we can see here, this oxygen will abstract the proton from sulfuric acid, and it will generate a intermediate species like this. Then the oxygen of this intermediate species will push its electron density in this direction, and this water molecule will get eliminated, and this nitronium ion will be generated. Now let us see how this nitronium ion will react with this benzene ring. So as we have discussed, the electron density from this benzene will come and attack on this positively charged nitrogen atom, and the electrons will be pushed towards the oxygen. Then we can see that an intermediate species is formed where there is a carbocation generated on this aromatic ring, and this aromaticity of this ring is destroyed. So we need to regain the aromaticity of the system. For that, a water molecule or some bases that will be present in the system will abstract this proton. Then electron density will be pushed in this direction, so as to neutralize this carbocation, and this nitrobenzene is formed. So as we have discussed, the correct option for this arrow pushing sequence is option A. Is this clear for everyone? Hope it is clear. Now let us move towards question number 2. So what is question number 2? When benzene and cyclopentene were mixed together in the presence of sulfuric acid, the expected product is. So the reactants for this reaction is benzene and cyclopentene. It takes place in the presence of sulfuric acid, and what we need to find is the product. Now what we need to find is the product, and we can see what is the mechanism that is taking place in this reaction. They have given 3 options, A, B and C. We have to find out the right option after seeing the mechanism of this reaction. So what happens when cyclopentene reacts in presence of H2SO4? It will generate a carbocation like this. In the presence of H2SO4, cyclopentene will generate a carbocation like this. Then the electron-rich benzene ring will attack on this carbocation. It will result in formation of this intermediate species. Then the base, or in like water molecule, it will attack on this proton, and electron density will be pushed in this direction so as to neutralize this carbocation, and aromaticity will be regained. So the resultant product is aromatic, a cyclopentane attached to this benzene. So we can see the options out of A, B and C. C is the right option as per the mechanism we have seen. So the correct answer is C. Is this question clear for everyone? Now I will move forward towards question number 3. What is question number 3? The 13C NMR signals are in the following order of chemical shift value, delta value, and they have given some options. So this is carbon A, this is carbon A, this is carbon B, and this is carbon C. So they have given 4 options, that the chemical shift value is like A equal to B equal to C, A greater than B greater than C, A equal to C greater than B, and A greater than B equal to C. Now let us see what is the criteria that distinguishes the chemical shift value. We have already discussed in the lectures that saturated carbon atoms like CH3, CH2, CH etc. will come in the chemical shift range of 50 to 0. And saturated carbon atoms like next to oxygen, like ethers, CH3O, CH2O etc. that comes in the chemical shift range of 100 to 50. And unsaturated carbon atoms like C double bond C and aromatic carbons, it comes in the range of 150 to 100. And unsaturated carbon atoms next to oxygen, that is the carbonyl, it comes in the range of 200 to 150. So we can see the different carbons in our system. This carbon A is olefinic carbon, or like it unsaturated carbon atom. It comes in the range of 150 to 100. And carbon B, it is CH2. So it is a saturated carbon atom and it comes in the range of 0 to 50. And what about C? it is part of an aromatic system. So it also comes in the range of 150 to 100. So we know that B is coming in the range of 0 to 50 and A and C are coming in the range of 100 to 150. So the correct option here is A equal to C, that is greater than B. This is the correct option. Is this clear for everyone? Now when we are asked, like we have already discussed in the lecture, previous lectures, if they have asked for the proton NMR signals to write in the order of chemical shift value, what will be the right answer? Anyone have any answer? Please feel free to unmute and answer. If they have asked for proton NMR signals to write in the order of chemical shift, what will be the right answer? Like sir have discussed in the lecture, this is aliphatic proton, like CH2. It comes below 3 ppm range, and this is olefinic proton. The proton that is coming here, this proton A is olefinic, and it comes in the range of 4.5 to 6.5 as we have discussed, and this is aromatic proton. It comes in the range of 6.5 to 8.5. So the correct order will be C greater than A greater than B. Is this clear for everyone? Now let me move forward towards question number 4. This is question number 4. They have asked, what is the intermediate that is formed during Friedel-Crafts acylation reaction? What is the intermediate that is formed during Friedel-Crafts acylation reaction? They have given 3 options, A, B and C. Which is the right option? So we can see the mechanism for Friedel-Crafts acylation reaction. So this is the mechanism for Friedel-Crafts acylation reaction. We have acid chloride, and in presence of Lewis acid like aluminium trichloride, this lone pair of electrons on this chlorine will form a bond with this aluminium, leading to formation of this species. Then the lone pair of electrons on oxygen push its electron density towards this bond, and this carbon chlorine bond will be broken, leading to formation of this acylium ion. Acylium ion is the intermediate in Friedel-Crafts acylation reaction. Then what happens? Then the benzene ring will attack on this carbon of this acylium ion, and electron density will be pushed towards this oxygen so as to neutralize this positive charge. It will result in formation of this intermediate species. Now the next main task is regaining of aromaticity. For that, a chloride ion which will be present in the system will abstract this proton and push electron density in this direction so as to neutralize the carbocation, and we get this acylated benzene system. So we have seen the mechanism for Friedel-Crafts acylation reaction. Now what was the question? What is the intermediate that is formed in Friedel-Crafts acylation reaction? They have given 3 options, and the right option is option number B. That is, this acylium ion is the intermediate that is formed during Friedel-Crafts acylation reaction. Is this clear for everyone? Now I will move towards question number 4. question number 5. Coming to question number 5. 1,3-dibromobutane has dash proton NMR signals. They have asked for the number of proton NMR signals in 1,3-dibromobutane. So before going to solve this question, we need to know the structure of 1,3-dibromobutane. So what is the structure of 1,3-dibromobutane? This is the structure of 1,3-dibromobutane. Here this is an unsymmetrical system. This is an unsymmetrical system, and all the 4 different carbon atoms are different. So it will appear as 4 different peaks in the NMR spectra. So the correct option is 4. Correct answer is 4. Is this clear for everyone? Hope this is clear. It was a simple question. Now can we move towards question number 6? Can we move towards question number 6? Coming to question number 6. The product of following reaction is. The product of the following reaction is, and they have given Friedel-Crafts alkylation reaction as the reaction. Benzene is there, and alkyl chloride is there, and a Lewis acid AlCl3 is there. So this is Friedel-Crafts alkylation reaction. So what is the product formed in this Friedel-Crafts alkylation reaction? And they have given 4 options. Which is the right option we need to find out. So we can see the mechanism of Friedel-Crafts alkylation reaction. So this is the alkyl chloride. So this lone pair of electrons on the chlorine will form a bonding with this aluminum chloride, leading to formation of this species. Then this carbon chlorine bond will be broken, and AlCl4 minus will be eliminated, and a tertiary carbocation will be generated. Then what will happen? This tertiary carbocation is attacked by this electron rich aromatic system. So electron density from this aromatic system will attack the positive charge on this carbocation. Then an intermediate species is formed, as we can see here. Now what is the last step? Last step is regaining of aromaticity. For that, chloride ion in the system will abstract the proton, and this carbocation is neutralized, giving this product. So this is the mechanism of Friedel-Crafts alkylation. I hope everyone is clear with this mechanism. So we can see the options they have given, and we can find out which is the right answer. So this was the question, and we have seen the mechanism for this question. And what was the right answer? As we have got option B is the right answer. So the answer is B. Is everyone clear with this? Is everyone clear with this? Now let me share my screen again. So we have seen the answer of question 6. Now can we move towards question number 7? Moving towards question number 7. Question number 7 is for the following compound. For the following compound, which of the following statements are true? They have given some statements for this following compound, for this compound, and they have asked which of the statements are true. So what are the statements given? They have given like chemical shift of A equal to chemical shift of B, chemical shift of this proton A equal to chemical shift of this proton B, chemical shift of B equal to chemical shift of C. Then they have given chemical shift of A is larger than B. Then chemical shift of A, B and C are identical. So how can we know about this difference in chemical shift in this particular species? For that we need to see the resonance structures of this compound. So this is the structure. Upon resonance, here this nitrile is an electron withdrawing group. It can pull this electron density on this aromatic ring towards it, leading to formation of this resonance species, where a carbocation is generated at this position. Then electron density can be pushed from this bond to this side so as to neutralize this carbocation, leading to formation of this resonance structure, where a carbocation is generated at this para position. And similarly, now so as to neutralize this carbocation, electron density can be pushed from this bond to here, so a carbocation will generate at this position. So what we can see from this resonating structures, that a positive charge is generated on ortho and para carbon. Ortho and para carbon. This is ortho carbon. This is para carbon. This is ortho carbon. So a positive charge is generated at the ortho and para position of this species. If a positive charge is generated means the electron density at that center is less. A carbocation is formed means electron density at that center will be less. We have seen that when there is more electron density, that system will be more shielded. More shielded species will come at lower chemical shift. So here ortho and para position have lesser electron density, means they are less shielded or de-shielded, and those carbon or proton will be coming in higher chemical shift, because as shielding increases, chemical shift will decrease, and as de-shielding increases, chemical shift will increase. Is it clear for everyone? So let us go back to the statements again. So we know that here at A, sorry, like everyone is not able to join. I think I have not given permission. Can I continue presenting? Okay, I will continue presenting. If you have any doubts, you can stop me in between and ask. Feel free to ask. So I will present. Now we can see. We have seen that at ortho position and at para position, the electron density is lower as carbocation is generated at that positions. A carbocation will be generated at ortho position and at para position. So this will be de-shielded and it will be coming at higher chemical shifts. Whereas meta position, a carbocation is not forming at meta position, so this will be more shielded and it will be coming at lower chemical shift. So the correct option is chemical shift of A is larger than B. B is having lower chemical shift as it is more shielded, but chemical shift of A is higher. So the correct option is chemical shift of A is larger than B. We can see the other options how they are wrong. They have given chemical shift of A equal to chemical shift of B. Chemical shift of A is higher compared to chemical shift of B. So this option can be ruled out. And chemical shift of B equal to chemical shift of C. Hello? Hello? Any doubt? Can I move forward? So chemical shift of B equal to chemical shift of C. So here, since a carbocation is generating at this position, here it will be de-shielded. Chemical shift value will be higher compared to that of B. Since it meta position, no carbocation is generating. So this option can also be ruled out. Then they have given chemical shift of A, B and C are identical. A and B can be identical, but not of B. So this option can also be ruled out. So the correct answer is chemical shift of A is larger than that of B. Is this clear for everyone? Hope it is clear. I am moving towards question number 8. So the next question is the intermediate that is formed during bromination of benzene is. So they have given 3 intermediates, option A, option B and option C. So what is the correct intermediate that is formed? It can be A, B or C or all of the above. We can see the mechanism for bromination of benzene before going towards the answer. So this is the mechanism for electrophilic substitution on benzene. So bromine can coordinate with a Lewis acid like AlCl3. Then when benzene ring will come and attack on this bromine, this group will eliminate and an intermediate as shown here will be generated. Now the next step is regaining of aromaticity. So for regaining aromaticity, any base or water that will be present in the system will abstract this proton and we will get this brominated benzene species. So we can see that this intermediate can be written in resonating forms. So instead of bromine, here they have given E, that is electrophile. So this upon resonance, it will, when this electron density is pulled in this direction, a carbocation will be generated at this position. Then this electron density can come towards neutralizing this carbocation. So a carbocation will generate at this position. So as we can see, there is positive charge at ortho position, para position and again ortho position. So positive in the intermediate there will be partial positive charge at this ortho position, para position and this ortho position. So the options they have given is A, B and C, where here this is the ortho position, in B this is the para position and in C this is the ortho position. So all these intermediates are forming during the bromination of benzene. So the correct option is all of the above. Is this clear? Hello? If you have any doubt, you can stop me in between. Is my speed okay? Am I going like very fast? Hello? Hello? Can we move towards question number 9? Moving towards question number 9. So for the following reaction scheme, identify the reagents. So for the following reaction scheme, identify the reagents. They have given here acylation from this starting material to this. In presence of these reagents A, acylation can take place. So what is the name reaction that is taking place here? Anyone can tell what is the name reaction that is taking place here? This is Friedel-Crafts acylation reaction. So what will be the reagents that can be used for Friedel-Crafts acylation reaction? So that we need to think. And from this Friedel-Crafts acylation product to this product, what is B? So in options we can see B like zinc amalgam and HCl. So for treating by treating this acylated product with zinc amalgam and HCl, this carbonyl group will be eliminated and it will generate alkane. So what is that name reaction? Is anyone aware about this name reaction? It is Clemmensen reduction. It will remove this carbonyl species and give alkane. So we can see which is the correct answer. So they as per option A, they have given CH3, CH2, COCl and B as zinc, mercury and HCl. So for Friedel-Crafts acylation to take place, there should be a Lewis acid also to be present. So this option can be ruled out. And the next option given is CH3, CH2, CCl. Is this correct? No, there is no carbonyl. So this option can be ruled out. I am not discussing about option B because option B is same in all the options given. Now the next option is CH3, CH2, COCl and AlCl3. So we can see in this product CH3, CH2, C double bond O. And we have seen the mechanism for Friedel-Crafts acylation reaction. So this is the right answer. So why not option D? Because they have given CH3COCl. If it is CH3COCl reacting, the product will not have this group. It will have only one methyl group attached to the carbonyl. So this option can also be ruled out. So what is the correct option? The correct option is CH3CH2COCl AlCl3, that is Friedel-Crafts acylation condition, and B zinc amalgam and HCl, that is Clemmensen reduction condition. Is this clear for everyone? This was simple question only. In this assignment only basic chemistry we are discussing. Is this clear for everyone? Now we will move towards question number 10. Coming to question number 10, they have asked the number of distinct signals in the proton NMR spectrum and they have given the species. So here we can see this is a symmetrical species. This is a symmetrical species, and like deuterium is NMR inactive. Its nuclear spin value is 0. So deuterium is NMR inactive. Here one proton is there. Here two protons are there. And this is tertiary butyl group. Here all the protons will be resonating at the same chemical shift. So 9 protons will be coming in the same chemical shift. So what is the number of distinct signals in proton NMR spectrum? Here these two will be identical. Then this, so from tertiary butyl 9 protons, these two protons, like it will be 1, so 1, 2 and 3. Correct answer is 3. Correct answer is 3. Is this clear for everyone? Correct answer is 3. These are the questions I am having for today. Anyone have any doubt in the lectures? If you have any doubt, you can feel free to ask. Anyone have any doubt? Otherwise, we can end the lecture now. We can meet again in coming Tuesday from 6 to 7. If you have any doubt, you can feel free to ask. Otherwise, we can end the lecture now. I hope everyone is clear with the answers I have discussed. So, thank you.